Riverside? Do you need to pull that back? There's a bar underneath. If you just grab the bar and pull up, it'll slide right back. Off the Riverside City College? Awesome.
What are you going to say before Robert came on the... You're starting to tell us something else.
I was going to ask a serious question here.
Oh, what?
If it turns out that let's just say, if it turns out that the Earth is flat,
yeah,
that's what happens. What are the Harlem Globetrotters going to call us?
That's your serious question. And that dates you, by the way.
Harlem Believe it or not, the guy that just said that is a submarine captain.
You believe it or not, they are. They, they're not what they were in the 70s and early 80s.
Say what?
What submarines are you allowed to control?
Why? Why do you say that?
He says that. Oh, right. Indian guy from the
Well, it has been proven over and over?
Yeah.
How?
Well, there wasn't there multiple rockets to go up in space to say that the Earth was round.
You mean like the moon landings?
No, that's actually right. No, I'm talking about the multiple space, satellites.
Oh, you're talking about those cartoon images they show you all the time.
Space satellites?
Yeah. Go back, go look at them, okay? And it's kind of strange that they have the same curve on those that you get with a barrel lens or a fisheye lens. Like whenever you see those high altitude balloons or those rockets go up, and people are like, oh look, I recorded the curve of the Earth, right? Like they show you like the beautiful Earth, and it's all round. It's a fisheye lens. The same lens is no different than if you were looking through like your peephole in your house. That's the kind of lens that's actually on the GoPros standard. Here's a good one. Think about this. Have you ever been outside and seen like Venus at night?
No.
You've never actually looked? Well, Venus is actually one of the brightest stars in the sky at night. Like, it's the only thing that really rivals it is the North Star. Okay? Well, if you can see Venus at night, and at night, isn't the Earth facing away from the sun? Right? But where is Venus in the solar system? It goes the sun. What's the next planet? Mercury. And then after that is what? Venus. So Venus is in between us and the sun. So technically, don't you have to be looking towards the sun to be able to see it?
I guess so. I'm really not sure about astrology, like really strong about it, but I'm following it.
Well, that's just very simple logic, though. You don't have to know astronomy or astrology or anything like that. Because, I mean, you could use your phone right now and Google order of the planets, right? And it'll show you the Sun, Mercury, Venus, Earth, Mars, Jupiter. So, Venus is the second planet. Earth is the third planet. If we go around in circles around the sun, you have to be looking in the direction of the sun to see Venus, no matter what. By what they teach us in school. Right?
Alright.
So, is this guy really all that crazy for thinking that maybe the world's flat?
No. Well, considering how history used to think that the world was flat anyway, I guess.
Well, it was actually taught in schools in America up until about 120 years ago that the world was flat. It didn't stop 500 years ago with Christopher Columbus.
No, it wasn't Christopher Columbus. He discovered America.
Well, no, but I mean, like 500 years ago, they were talking about or even the Greeks 2,000 years ago with Aristophanes, okay, where he put the two sticks in the ground and told the distance of the sun. He actually gave two different distances. Or what about so much of science is based off of gravity, right? Now, is gravity a theory or a law?
Well, it could be considered to be both because gravity, you know, from what many people have said, that gravity is what can I
It's
say?
technically classified as a theory. And on top of that, I don't think it holds any water. Because Newton came up with the equation for gravity, right?
Yeah.
It's Fg equals big G m1 plus times, okay, it's big G times m1 plus m2 over r squared. Okay? The m1 is the mass of the earth, which means Newton in the 1700s would have had to have known the mass of the earth. The big G is the gravitational constant. Now, that gravitational constant wasn't found until a guy by the name of Henry Cavendish calculated it. Problem is that Henry Cavendish didn't calculate it for over 100 years after Newton. So what good was Newton's equation? He didn't know 3 variables in the equation. Are you in any kind of math? Do you remember any kind of math from school? Now, to solve an equation, don't you have to know, if you're solving for a variable, right? Don't you have to know the other information in the...
Yeah, because even
unless you're going to have an unsolved equation, right?
Yeah, because even if you miss one letter, then the whole variable's wrong.
Exactly. So, what was he actually calculating? And it was over 100 years later. That equation had no bearing on anything because it could not be completed. Why would it be remembered for 150 years?
Unless the guy who did the equation 100 years later did it, you know, for
or
himself.
Unless now, a few hundred years later, they look back because hindsight's 2020. All right, they were able to see Cavendish's experiment, which, by the way, do you know what his experiment was to find the gravitational constant? He hung lead balls in his shed. I don't understand how that, because now you have all kinds of variables in there. Because that crossbar that those things are attached to is being held by something. You have to take that into account. He didn't have it just floating gravity free or weightless, you know? It still had some kind of tension on some kind of... Every experiment I've seen for this has it hanging from something. And nobody ever takes that into account. And I'm like, it's a faulty experiment. Especially if you're trying to calculate something so fine. Especially something called the gravitational constant. Right? Isn't it supposed to be constant with a name like that?
Yeah, it's supposed to have the same results every time.
Yet every time it's measured, it's a different number. Now they give you a range. So there's a range of numbers for the gravitational constant. That doesn't sound too constant to me.
Sounds like it varies.
Sounds like there's a flaw in the experiment.
Wait a minute, you talking about the okay. It's been a while since I thought about something.
Where they hang the smaller balls,
and then they go like
and then they put the heavier balls next to it,
and then they rock it back and forth,
and then it slightly rocks back and forth.
Okay, it's that experiment.
Yeah. That experiment was done over 100 years after Newton's equation of gravity. Or, have you ever seen, or can you think of any kind of example where a vacuum and a non-vacuum are able to coexist next to each other without having some kind of barrier in between? Like a soda can is a vacuum, right? Out here is a non-vacuum, right? What happens if you puncture the soda can?
Pressure releases.
And it creates equilibrium, right?
Yeah.
Now, space is a vacuum, right? Earth is a non-vacuum, right? Now, what solid barrier do we have in between space and Earth?
The ozone layer.
Okay, I'll give you that one. But now, when you talk about launching rockets into space and stuff like that, aren't you punching holes in the ozone layer?
Yes.
Oh, or don't you remember like 10 years ago or so where they were talking about the giant hole in the ozone layer? That's why we're not supposed to use normal hairspray cans anymore?
I remember some parts of it. I remember saying...
So now they're trying to tell us that there was a hole in the vacuum, but it was still a vacuum. Right? I mean, and these were news reports saying that there's a hole in the ozone layer. So there's a hole in the soda can, but yet all the soda is staying inside the can. Does that make any sense? Or can fire burn without oxygen?
No, because when you put any type of oxygen,
You can starve it.
Yeah.
You can starve a fire. Space has no oxygen. The sun's a big ball of fire. How is it burning?
Is it burning? I know it's a star. And I know that the sun itself, yeah, it's a star.
It's still on fire.
What is it?
They say that it's hydrogen. But even hydrogen, when it combusts, turns into fire and needs oxygen to continue. Doesn't it? Or like the rockets that they use. How are the rockets burning in space?
And there's no fire or there's no oxygen to keep it alive.
Or on top of that, when they go to steer, right? On Earth, when we use a plane or something like that, and we steer to the left or the right, we have little fins, right, that guide us. And they actually press against the molecules of the air. And that's what guides us, is us hitting the molecules of the air. So in space, when they go to steer, what are they steering against? But yet, supposedly, they're able to move that rocket wherever they want. Things are a little bit different when you stop the indoctrination and you actually think about things for yourself and not just what you've been taught in school. Because in school they also teach us that the core of the earth is a big responsibility for gravity, right? We have a molten magnetic metal core. That's what they tell us. Now, first off, what happens to a magnet when it's melted? It loses its magnetism. It's no longer a magnet. So then, with that being said, they don't even know what's down in the middle, because they tell us in the science books that it's 4,000 feet or 4,000 miles to the center of the earth. Each rock, you remember those pictures in school where the earth looked like a big old jawbreaker?
Yeah, they have multiple layers, and the biggest layer was like the hottest part of it.
Yeah, and each layer is like 1,000 miles deep, right? They're really, really deep. Well, with them putting that in the book and teaching you that as a fact, how far down do you think the deepest hole ever dug is? How far down were they able to dig?
I'm not saying they have to go through lots and lots of rockland. I don't think you.
So let's say maybe like, what would you be comfortable with 1,000 miles if they went down 1,000 miles? Because that's a quarter of the way.
No, but how can they go 1,000 miles? I think it's deeper than that.
Well,
So I
they
think
tell us it's 4,000 miles. But what I'm asking you is, what's the deepest they could go that you would be comfortable with them telling you what's in the middle?
I say maybe 10,000 miles.
10,000 miles?
Maybe even a little bit more than that, because I don't even think it's just 4,000 miles, because even if you try to dig 1,000 miles, I think you'll still be surrounded by a bunch of dirt and rock.
Yeah. Well, here's the thing. Deepest hole ever that's been able to be, that anyone's been able to dig on Earth was done by the Russians, and it took them almost 10 years, and it only went down 8 miles. At a 4,000.
That's all.
That's a little bit off, right?
Yeah.
Yeah. Turns out it's 0.002% of the distance they're telling us. That'd be like if you had never seen a coconut, right? Like one right off a tree with the green husk around it still, right? And I hand you a coconut and an X-Acto knife. You know, one of those knives that looks like a
There
pen?
you go, like that.
Okay. And I tell you, stab this all you want. Tell me what's in the middle. Would you be able to? Would you feel comfortable telling anybody what's in the middle of that? Right here?
No.
But yeah, would you feel comfortable telling anybody that?
Because isn't that coconut technically unripe? And then, or is it ripe? No, it's unripe.
No, it's right. It's sweet on the inside. Young coconut, yeah. Right here.
No, the second one.
Second one. At the stop sign.
Yeah.
Gotcha. But yeah, so, and your first thought of, oh, this guy's crazy because he believes a flat Earth with the sub-captain, you were trained to think that right off the bat. Let me ask you something. When you first heard him say flat Earth, what'd you picture in your head?
Well, I kind of went back to how they were thinking, how they were interpreting stuff right over here.
Were you thinking about like a Christopher Columbus style ship falling off the edge of a bunch of water, like floating over the edge?
No, because Christopher Columbus came like 500 years later. Before America was discovered already, so he came many years later. So I thought of the guy that they named America after, Americano, going past America, thinking, oh, the Earth is, not flat. There's actual other sides of the Earth. That's what I thought. But then I thought about it, and he was like, maybe you're right, because Pangea, they said that it split the world, but maybe it's not split.
See you later.